This is Math 141, practice test number 2, problem number 16. And we're given a situation where the initial size of a population is 3,000. After 2 hours, it's grown to 4,500. We're going to assume this change is exponential, that it's growing exponentially. And then how many things will be there after 5.5 hours? So, first thing we'll start with is trying to figure out some sort of model for this. So I'm curious that it starts with 3,000. It's growing continuously. And after 2 hours, at some rate, it gets up to 4,500. So notice how I set that up. I have my initial amount of the amount I ended up with after 2 hours. I know it's growing continuously, so I'm just curious about the rate. I'm trying to find how fast this is growing at. And then I can, after I know what R is, I can go back in and plug in 5.5 hours for that. I'm basically basing it off of the relationship. The amount that I have is what I start with, times e to the rate times the time. And I let the time, I knew the time was 2, so I plugged that in. I'm just trying to find the rate. And I wrote it as like money, but it does for populations too. It could be the population at a certain time, or the starting population, and then the amount at a certain time. So let's solve this for R, and so we can figure out that rate of growth. So I divide both sides by 3,000, and over here that divides out. So I have e to the 2r. And over on the left side, I have that 4,500 divided by 3,000. You can leave it like that. I want to reduce it to 45/13ths, but you don't have to do that. Still solving for r, I am going to natural log both sides to deal with that e. So natural log of that is 2 times r. Sorry, let me rewrite that. That was pretty sloppy. Equals 2 times r. Still solving for r, so now I'm going to divide both sides by 2. So I have this r is equal to natural log of 45 divided by 13, that whole thing divided by 2. Shove that into my calculator, and it's about 0.6209, and the further I go out, the more accurate I'm going to be. I'm going to go out 4. It's pretty good. So that means that my model for this now is 3,000. That's my starting population, times e to the power of that growth rate. That's about 62% times t. So now if I just want to know it after 5.5 hours, I can just plug that in for my time. So 3,000 e to the growth rate times 5.5. And in my calculator, I rounded a lot. I'm not sure, how far off I am. So I'm going to be pretty conservative. I'm just going to round to the hundredths place. So I would say about 39,500. About. So after 5.5 hours, my population should be around there.